Masses M and 3M are connected by a string which is stretched over a pulley. The masses are released from rest. Determine the magnitude of acceleration of mass M. So this is the pulley, and we are going to find the solution of the question. The 3M mass is being pulled in one direction by the force of gravity. The mass is being pulled in the other direction also by force of gravity. So we are going to find this equation. So the acceleration is gonna be 1 over 2 gravity. A 50-kilogram roller coaster car is initially at rest at the top of a 25-meter high hill. When it's released, the car rolls down the hill and passes through a loop that has a radius of 10 meters. Determine the speed of the roller coaster when it reaches point B at the bottom of the hill. So this is the diagram of our question, and we are going to use this equation for finding the answer. So the kinetic energy is equal to potential energy, and this is mean so this is gonna be the answer. Determine the acceleration of gravity in terms of g at a point in space that's located in a distance equal to 2 Earth radii above the surface of the Earth. This is orbitals involve circular motion. The centripetal force is the sum of the forces acting on the mass and directed toward the center of the circular motion. For planets, that's the force of gravity. Since the mass of the orbital body cancels, all planets at the same radius will have the same orbital speed. So the centripetal force gonna be equal to force of gravity, and this is gonna be mean this. So we can find 1 over 9 gravity, and this is gonna be the answer. An object is thrown horizontally at a velocity v from a bridge that's height y above the water. How long does the object take to hit the water below? So, an object is thrown horizontally at a velocity v from a bridge. And this is gonna be the water. And this is the height. So we are going to use this equation. This is going to be acceleration and this is going to be gravity. And so we can find the time is going to be the root 2y over g. This is going to be the answer of the question. An astronaut weighs 600 Newton on Earth. What's the astronaut's mass on the moon, where the acceleration of gravity is 1/6 that of Earth? So weight means mass multiply gravity, and mass is not affected by change in the acceleration of gravity. So it's gonna be 600 Newton. So the astronaut's mass on the Earth is gonna be 60 kilogram. An astronaut discovers a planet with 2 moons. One moon is 2 times as far from the center of the planet as the other and 3 times the mass of the other moon. What's the ratio of the gravitational force on the first moon to the gravitational force on the second moon? So this is gonna be the planet, and this is the radius of the planet, and this is the same. This is gonna be 2r, and this is gonna be 3 radius. So the first is gonna be this. We are going to apply this equation. So the answer is gonna be 0.75. This is gonna be the answer of this question. A hiker walks due north for 3 kilometers and then due east 4 kilometers. For 3 kilometers and then due east 4 kilometers. How much shorter would the walk be if the hiker walked in a straight line from the starting point to the displacement? So the hiker walks due north for 3 kilograms, then toward east for kilometer, not kilogram but kilometer, and how much shorter would be the walk if the hiker walked in a straight line from the starting point to the displacement. Then you can find this is going to be starting point and this is going to be ending point. So we can apply this. Pythagoras theorem, according to Pythagoras theorem, this is gonna be this. So this is also the one of answer to find this distance. The distance the hiker walks originally is 2 kilometers is shorter than original way if the hiker walks in the straight line. So this means the answer is not this 8 plus this is gonna be 7, but this is not gonna be the answer. We can find the 5 is gonna be the answer of this question. So 5 is the answer. 5 kilometers is gonna be the answer of this question. A 6-kilogram block suspended from the ceiling. The force exerted on the block by the cord is approximately. So the mass is 6 kilogram and the block is in equilibrium. The force exerted by the cord on the block is equal to opposite in direction to the weight of the block. So weight is equal to mass times gravity, and this means 6 times 10 and 60 Newton. Is gonna be the answer. You can find the value 60. The work done in holding a weight of 20 Newton of a height of 1 meter above the ground for 5 seconds in joules. So this is gonna be this. This question is asking about the work. So the height is going to be 1 meter. and we are going to apply this equation, and there's no change about this distance. So although a force is exhausted, the object does not move as a result of the force, so no work is done. So 0 Newton is gonna be the answer of this question. An inclined plane with a length of 8 meters that's lifted 2 meters above the ground on the end. A person needs to push a 700 Newton object up the plane. The force of friction is 50 Newton. So what's the potential energy gained by the object when it's raised to the top of the plane? Approximately what's the minimum force required to push the object up the plane? So this is gonna be the inclined plane, and this is gonna be our object. This is 8 meters, and this is 2 meters, and the weight of this object is gonna be 700 Newton. So the force of friction is gonna be 50 Newton, and we are going to apply this equation. The potential energy is gonna be this Newton times 2 1,400 joule, and we are going to find this. The person need to overcome this, and the force of friction is gonna be so 1,400 joules is gonna be the potential energy gained by the object when it's raised to the top of the plane. And after that, we are going to apply this. So the sign is gonna be this value. This is our sign value. So we can find the 225 Newton is gonna be the answer of the second question.